Good morning, sixth graders. Emily, Ashley, Cheyenne, and Delcy. It is Thursday morning and hope you had a restful night. Today is a new day and we are ready for lesson 12 and excited about your lesson today. Your lesson today, you're just learning some interesting facts about numbers, not necessarily anything new that you're going to need for the next year, whatever, but just some interesting facts about numbers. Remember, God created numbers and God makes things so interesting and so unique, and the numbers that we're learning about today is one of those unique things. So on page 46, I hope you're going to follow along with me, and we're talking about patterns in numbers. All right, it says, look at the patterns formed by the following. And I wrote this up here on the board, what you see in your book right up there at the top. We have a double 6, and then we went to a double 12, a double 24, and a double 48. What they are wanting you to notice, you see a double 6 is 12. Okay, look at this back number, the ones place in the numbers. All right, so we have a 2, then we have a 4, and then we have an 8, and we're back to a 6. Now, if you think about it, a double 6 is 12. Double 12 is 24, and look at your patterns, 2, 4, 8, 6. 2, 4, 8, 6. All right, so now let's look at double 96. Here was a double 48 was 96. Double 96 is back to a 2. A double 192 is 384, you're back to a 4. Double 384, here's an 8. See what we've got? 2, 4, 8, 6. 2, 4, 8. What do you think this guy is going to be? A double 768, what number should it be? 2, 4, 8, 6. 2, 4, 8. Think that's a 6? Let's use our calculator. 768 times 2, 1, 5, 3, 6. What do you think a double 1, 5, 3, 6 is? Think it's going to be back to a 2? Let's look. 3, 0, 7, 2. How interesting is that, guys? 2, 4, 8, 6. 2, 4, 8, 6. 2, and if you kept going, I'm thinking it'd probably be 4, 8, 6. So neat. All right, they have some more things for us to look at. On number 1, it says you can use your calculator. It says do these exercises. All right, this is going to be some more patterns. Let's see what else we can learn. It says to double the 3 and then see the result. All right, so if we have 3 and we double it, we're going to have 6, right? Then double it again. So if we double 6, we have 12. Then double the result again, so we have 24. What pattern do you see in the ones digit of each product? All right, so we doubled the 3, and here's the ones digit. We have a 6, 2, 4. What do you think? Let's double the 24, would be 48. Double the 48, we have 96. We're back to a 6. 3, 2, 4, 8. I'm sorry, 6, 2, 4, 8. 6, 2, 4, 8. I bet it would keep going. It says, what pattern do you see in the ones digit of each product? They want you to write these right here. 6, 2, 4, and 8. Put you a comma. Something like this. You should write something like this. So if you double 3, you get 6. Double 6, you get 12, 24, 48, 96. And you have these patterns that just keep right on going. All right, let's look at another pattern. It says multiply 67 by 101. So if we go 67 times 101, we come up with, guess the result. This is so cool. If we multiplied 67 times 101 equals 6767. So multiply 23 by 101. What do you think we're going to get? We have 2323. Multiply 82 by 101. What do you think you're going to get? 8282. Do you see the pattern? You guys see this? 67 times 101 is 6767. 23 times 101, 2323. 82 times 101 is 8282. Without multiplying, write the products for these. Okay, you're supposed to not multiply by the calculator, just write it in. What do you think it would be? 12 times 101 and 35 times 101 and 56 times 101. Write in your answers, guys. This is so neat. God designed our world in such a unique way, and even down to our numbers, we think, it's just math. What do we need math for, and what's so interesting about math? When you start studying this and looking at this, I think God created these unique things for our enjoyment. It's very interesting. All right, y'all finish up those blanks, and I'm going to write out your next chart here. So if we have, I think they have, this looks like they might have these written in for you, these first couple. So they give us an idea. I think the next one, 6 and 2 is. So if we have a box that is length and width, just like this, our width is 1 and our length is 3. And our perimeter, remember, is 2L plus 2W. So 2 times length plus 2 times width would be 6 plus 2 would be 8. 8 centimeters. And remember our formula for area, let me write this down. PL plus P equals 2L plus 2W. Area equals length times width. So if we wanted to figure out our area, we would go 3 times 1 is 3. All right, it says, complete the table beginning with the rectangle 3 centimeters by 1 centimeter, then double the dimensions for each rectangle. Recognizing the patterns will save you some work. All right, let's look what we can find out here. It says by doubling these, let's figure out what our perimeter and area would be for these. So doubling 3, we'd have 6. Doubling 1, we have 2. All right, to figure perimeter, it's 2L plus 2 width. So this would be 2 times 6 is what? 12. Plus 2 times 2. So we've got 12 plus 4 is 16 centimeters. And when we multiply them together to get area, we would go 6 times 2 is 12. All right, so let's look a little bit. Let's double. If we would again double this, would be 12 centimeters and 4 centimeters. Look what happened. 3 times 2 is 6, times 2 is 12. 1 times 2 is 2, 2 times 2 is 4. 8 times 2 is 16, times 2 is 32. 3 times what is 12? Ashley, 3 times what is 12? Delcy says 4, you say 4, so yes. So let's go 12 times 4 is 48 centimeters squared. Now let's check ourselves. To get perimeter, remember it's 2 times 12 plus 2 times 4. 2 times 12 is 24 plus 8, 32. And 12 times 4 to get area is 48. Now look at this, isn't this cool? So let's again double it. We went 3 times 2 is 6, times 2 is 12, times 2 is 24. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. Here we went 3 times 4 is 12, times 4 is 48, times 4 is 192 centimeters squared. It says when the length and width are doubled, that's what we did, we doubled these, the previous perimeter and the area is 4 times as much as the previous area. Oh, no, I'm sorry. The area is 4 times as much as the previous area. That's right. So the perimeter is doubled every time. The area is, what do you call it? It's times 4. I'm not sure the word that I want to use would be times 4 every time. So that's just some interesting patterns in your numbers, and maybe you know some that we don't know. But that was just something kind of fun to learn today. Down at the bottom of page 47 on your We Remember, number 12, you have a calculator there. Remember, it's 3 times 3 times 3 times 3. You're multiplying 3 4 times, okay? So be careful of those. Sometimes you guys get those wrong. Up on the top of page 49, number 24, you're going to go again back to your menu and figure up some ice cream. It says Lavita bought 3 cones and a quart of ice cream. The first blank, you're supposed to figure the cost of just the 3 cones. Figure the cost of the 3 cones without tax. The next blank says what was the cost of all the ice cream. So it's going to be the cones and the quart. Add them all together without the tax. Then the last blank is to the nearest cent, what was the cost with the tax. So you will take blank B and you will figure tax on that. And that will be your final blank. Blank number 25 is a several step problem. Mr. Eby paid the following electric bills last year. He's got a bill for January, February, March, and April. Based on the average of these 4 months, how much of his income should he budget per week for electric bills? Okay, this is again a budget question. So the first thing you have to do is how much did he pay? How much electric did he pay for all 4 bills? Okay, there's 4 of them. You need to know what he paid all together. And then he wants to know, these are for 4 months. So what you have to figure is, what was the average that he paid per month? There's 4 of them. So once you figure how much he paid all together, then find how much he paid per month. You're going to divide by the number of months that there are. How many months did he have electricity? He's got January, February, March, and April. How many months is that? Once you do that, then they want to know how much should he budget per week. So, so then after you figured up the month, what was his average per month, then there's how many weeks in a month? How many weeks do we usually figure in a month? That's 4 again. So again, you're going to divide by 4 and you're going to round to the nearest dollar. All right? It's going to be a 3-step problem. Down on the bottom of page 49 is a little bit more of interesting patterns that we learned today. It says, write the next 3 fractions in each pattern. Then write the numbers in each pattern. Are they increasing or decreasing, or are they equivalent, or that means equal? Are they all equal? So the first problem, you see the denominators are all 12, okay? The denominators are all 12, and the numerators are consistently getting bigger. They started out with 1, 2, 3, 4, then write the next 3. So now, are the fractions getting bigger or smaller, or are they staying the same? So maybe you don't know how big or how small 1/12 is, but look at 2/12 or look at 3/12. Reduce that. What is 3/12 reduced? 3/12 reduced is 1/4. All right? So we know what 1/4 is. How about 4/12? Let's reduce that. What's 4/12 reduced? 1/3. Now, maybe you know. So is going from 3/12 to 4/12, which is going from 1/4 to 1/3, is that getting bigger or is it getting smaller? Think about a cup measure that your mom uses, or maybe you've baked cookies already and you need a 1/4 cup of sugar or a 1/3 cup of sugar. Which is the bigger cup? If you don't know, go to your mom's cupboard and look, okay? That will help you decide, is it getting bigger? Are the fractions getting bigger or are they getting smaller? All right, and if you look at the next one, the numerators are staying the same. The numerators are all 1s. The denominators are getting bigger. They're going from 1/2 to 1/3 to 1/4 to 1/5. Keep going on the next 3. All right, again, is 1/2 bigger or smaller than 1/3? If you don't know, again, go get a cup in your mom's measuring cups that she would use to measure flour or sugar or something like that. See if 1/2, where does 1/2 come in relation to 1/3 and 1/4? Sometimes we need to look at something like that to help us get a picture of which is smaller, which is bigger, yes. And then looking at number 31, you see what the numerators are doing? 1, 2, 3, 4. What should you put for the next numerators? The denominators are going 2, 4, 6, 8. They want you to keep going. Now, are these are these fractions increasing, decreasing, or are they the same? What is 1/2 and 2/4? What do you think? Reduce 2/4 and tell me what you come up to. Reduce 3/6. Tell me what you come up to. Then you should be able to decide if it's increasing, decreasing, or equal. All right, that is your math lesson for Thursday. Have a great day and see you tomorrow.